There is one tiny chip that completely changed electronics forever. It is called the 555 timer. From making notes to generating sound waves, alarms, powering digital display boards, and even building darkness detector circuits, this little IC has been everywhere since 1972. Today, I will show you how the 555 timer works and how you can start building circuits with it right now. Here is the pin explanation of the 555 timer IC. The 555 timer IC consists of 8 pins. Pin 8 connects to the positive of the power supply. Pin 1 connects to the 0 volts of the power supply, that is the negative terminal of the power supply. Pin 2 is called the trigger pin. Pulling this pin low will start the timing, and that can be done with a switch, as you can see in a monostable circuit, or by its own circuit when you connect a discharge pin 6 to pin 2. That's if it's in an astable mode. You can actually connect pin 2 back to the chip and it's kind of re-trigger itself as well. Pin 3 of the 555 timer is called the output pin. This is connected to whatever you're trying to control or time with a timer. It could be an LED or a speaker, maybe even a motor that you want to move from a certain point to another in a certain amount of time. So pin 3 is the output, that is logically high or low to control a load. Then pin 5 is called the control pin, which is not really in use in most cases, but it's the pin that you use to create stability, that's to filter noise through a ceramic capacitor. So when you leave it without connecting anything to it, when you leave it dormant, it still does not have any effect on the 555 timer. The goal here is just to create stability, although sometimes it can be used to adjust the timing, but you can leave this pin dormant and you're good to go. Then pin 4 of the 555 timer is called the reset pin. Connecting this pin low means the chip timing will reset. This pin should be held high if the chip is to operate. You can liken this same pin to your calculator reset pin. Your calculator reset button, when you press it, it turns off the calculator, right? It's the same thing that happens here with the 555 timer reset. Connecting this pin low means the chip's timing will reset. So this pin must be held high if the chip is to operate. Next pin is the pin 6, the threshold. This pin monitors the voltage across the capacitor and therefore it's measuring the time it takes the capacitor to fill 2/3. The next pin is called the discharge pin, which is the pin 7, which is the last pin. This pin is used to discharge the capacitor once it is full. So these are the 8 pins of the 555 timer IC. So the secret inside the 555 timer is that there are 3 main parts. First, we have 2 comparators, like referees that compare voltages, as you can see on screen. Then 2, you have a flip-flop, like a memory that remembers the on and off state of the 555 timer. And third, you have a discharge transistor, like a drain that empties the capacitor. So in plain English, the capacitor charges up, yeah. So when it's too low, the output goes on. When it's too high, the output goes off. And these circles make LEDs blink or buzzer beeps or generates a signal pulse. So this is the secret behind how the 555 timer works in a nutshell. The 555 timer IC operates in 3 modes, which is like switching the gear of a car. First we have the monostable mode, next we have the astable, and then we have the bistable mode of the 555 timer operation. This circuit is configured in a monostable state. Mono means single. So a monostable circuit means it has a single mode or single operation, and that will be demonstrated if we press the button the red light will come on for an amount of time and then turn off. So we just get one single pulse, and you can see the 1 time delay from pressing the button. So everyone thinks that this is called a 5-5 timer, therefore it makes time delays, but it doesn't actually make a time delay. But what it does is that it measures the time it takes the capacitor to fill up with energy. All right. So it's not a timer, it's a measuring device or a measurement device that measures time. So when we push the switch, we are connecting the trigger, which is the pin 2, to 0 volt. And when it's not pressed, it's pulled up high by the pull-up resistor. So the red LED is on all the time. The capacitor is filling up. And when it's 2/3 full of the supply voltage, it switches back. Now, there are several things going up there. While it's filling up, the threshold pin is monitoring the voltage. When it gets to the 2/3 of the power, the timer reconfigures itself, and what it does is that it stops giving out current to pin 3. So the red LED can no longer light, and it also wires the discharge pin, which is the pin 7, to empty the capacitor, since it connects to pin 6 that knows when the capacitor is full. Also, you can change the time delay through the resistance in the way of the capacitor from your ROC capacitor concept, where the time is equal to the resistance of the resistor multiplied by the capacitor. So increasing either the capacitor or resistor increases the time delay, and that is 5-5 timer. The next mode of the 5-5 timer IC is the Astable mode, which is like a free running oscillator. This means it keeps blinking on its own like a clock. So if you get pin 2 connected to itself or connected back to the capacitor, then it's what's called an Astable timer. So you can see pin 2 connected to the threshold pin. So when it's empty, pin 2 triggers itself. So when we look at the output, we can see a current flow of sinking source. So you can make the flashing happen quicker by charging the capacitor, all right, when you make the resistor smaller. So when you make the resistor smaller, the capacitor fills up quicker, all right. And when the capacitor is charging at a very fast pace, if you hook the output to a speaker, I mean the output that was initially put to these 2 LEDs that are blinking right now on screen, if you now put it to a speaker and you make it flip back and forth quicker by reducing the value of the resistor, so when the output is now flicking faster, all right, your speaker will be vibrating and you will be making notes. And by changing the dial, which is the variable resistor now, you will be varying the pitch of those notes, as you can see on screen. Okay, because sound waves are just frequency speed up or slowed down. All right, so it's the same principle. In this instance, it's self-activating. So what happens is, when you power the circuit up for the first time, the capacitor fills up. The pin 6 monitors its filling up by the way it's filling up through 2 resistors. And when it gets to 2/3 of the supplied voltage across the capacitor, the 5-5 timer rewires itself to empty it, as well as pin 2 connecting to pin 6, all right, to negative emptying. So, and then because pin 6 is connected to pin 2, it triggers the whole thing again, and the circle repeats itself. So this is how the chip empties itself when it gets full. It empties it through the discharge pin 7, and the emptying causes pin 2 to read low, and the whole process begins again. So when it's full up, So when the capacitor it fills up, it's spinning up through two resistors. But when it's emptying it's only emptying through one resistor, as you can see on screen. So if you think about that, because it got less resistance for emptying, since it's using just only one resistor, it's going to empty quicker than it fills up. So what that means is, if we slow the time delay down and make the resistance bigger, when it's filling up, it's technically up for longer than when it's emptying. So in real terms, one of the LEDs is on for another slightly longer amount of time. Can you pause the video and check these circuits to figure out what's going on, and let me know in the comment section below. This on the left is a monostable circuit as we've discussed earlier, and the right is an astable timer circuit. But what I have done is that I have hooked up the output of the monostable circuit on the left hand side to the reset, which is the pin 4 of the astable timer circuit. So if I press the push button, which is in the monostable circuit, the light on and off for an amount of time, and then it stops. So here is a monostable timer circuit controlling how long an astable timer can flash for. And the reason it controls how long is because I am connecting the reset pin, pin 4 of the astable timer circuit, to the output of the monostable circuit. So from learning how this works, you can build a timed zebra crossing or railway crossing system, because you can set the resistor and the capacitor of the monostable circuit from the formula T equal to RC to discharge at any time of your choice. So this can be also an alarm for a house if you put an alarm at the output to vibrate at a set time. Alright, so combining 555 timer with other circuits can make you build amazing things. It even gets amazing when you even combine it with decay counter circuits to build things like digital displays. So why exactly do we need to care about these circuits? Well, they are some sort of useful in their own, and when you combine them in other circuits, they become even more useful. For example, understanding the monostable state of the 555 timer can help you make a simple kitchen timer or some kind or part of a system for like entry delay. All right, building an alarm for an entry delay. So they are also used in the interior lights in cars. Like when you open the door, the lights will come on for an amount of time and then turn off. For instance, pressing the switch light that comes on after a few seconds, once the door is closed, it will turn it off again. Then for the astable timer, you can take it to be your railway crossing light, just alternating lights back and forth. Maybe zebra crossing that has its warning light for such purposes. And if you could connect this to a speaker, the speaker would be clicking on and off. All right, and if you do it fast enough, you could actually generate sounds, as you can see and hear on screen. All right, so you can also hook them up to other things like decay counters to build digital display boards like this one on screen, where there are stable modes, sends an on and off pulse to a decay counter to run the LEDs in sequence in order for the display. So this could also be random number generator or bike lights with LEDs going back and forth. All right, so they are useful in building blocks to other circuits to make bigger things, like even creating the oscillation to run on a square wave inverter circuit. All right, so I'm going to be dropping some of the projects that I've made from using just the 555 timer. You should pause the video there. As you see, this project and try to analyze how the various project works, like the darkness detector and every other project. All right, and drop your question regarding each of the projects I'm going to be posting, and tell me what you understand about those circuits. And if you have any challenge with my explanation of the 55 timer, or you have any suggestion about how to use it better, please drop it in the comment section below. I would like to hear your viewpoint about the 55 timer and also about its relevance, although most of us just work with microcontrollers. So I would want you to let us know your experience with the 55 timer. Tell me how many projects you've been able to build with it. Just say something about it in the comment section below and analyze the circuits and let me know how the various circuits works. And please don't forget to like this video so the YouTube algorithm can recommend this video to other embedded system lovers and other electronics enthusiasts. So like this video, and if you are new to this channel, don't forget to hit the subscribe button, subscribe to my channel, and share this video. Thank you for watching. See you in my next video, and bye bye.